So the Fourier law describes the steady state problem, conduction problems, right?
Yes.
What is the meaning of a steady state? Just take example, your regular example of your home, right? So take example of heating the cold water on a stove, right? So when you heat the cold water on a stove, after some time, your water get hot, correct?
Yes.
And it reaches its maximum temperature condition, like boiling temperature condition, correct?
Yes.
It means the temperature is stable,
Yes.
no longer change in the temperature.
Yes.
Then it's called, it reaches the steady state condition. Clear? Eh? Clear?
Yes, sir.
Right? You understood?
Yes, sir.
When we call steady state, there would not be any change in the
Temperature.
right? So there would not be any change in it. It reaches the steady state conditions, right? The temperature becomes stable. Temperature become stable.
Yes.
The advantage of a steady state analysis is that it simplifies the system by avoiding very long duration run to get stable results. Getting it?
Yes.
So what is the meaning of steady state thermal analysis here? So this we understood by, steady state means your temperature get stable, right? So
Yes, sir.
the example is like heating the cold water on a stove, right? Now,
Yes, sir.
if I say, what is the meaning of the steady state thermal analysis? Any idea?
Analysis in which temperature has reached to certain level and now it's not changing.
Very good. So steady state thermal analysis can be used to determine the temperature distribution, the flow of temperature, right? How the temperature is distributing from one surface to another surface, one body to another body, right? So that
Yes.
you will get it. So this is one thing. So steady state thermal analysis is used to determine the temperature distribution. Thermal gradient we call as a thermal gradient, right?
Yes.
And heat flow, how much amount of heat is flowing from that object, and heat flow in an object. Clear?
Yes, sir.
So steady state thermal analysis is used to determine the temperature distribution, thermal gradient, heat flow in an object or a system of a heat transfer that reaches the steady state condition. And we already have saw what is that steady state condition, where the temperature gets stable, right? It reaches the steady state condition with a thermal load that do not vary with respect to time.
Yes.
Right? I'll repeat once again. What is the use of thermal analysis? What is the use of steady state thermal analysis? It is used to determine the temperature distribution, thermal gradient, heat flow in an object or a system of a heat transfer that reaches the steady state condition with a thermal load, maybe like in the form of temperature, convection, right? Radiation,
Yes.
anything with a thermal load that do not vary with respect to
Time.
time, right?
Yes, sir.
The heat transfer in a steady state thermal analysis includes conduction, convection, and radiation, right? So
Yes.
in FEA, the most of the thermal analysis are preferred to be have a steady state thermal analysis. Getting it?
Yes, sir.
Understood? So you will get the
Yes.
output in the form of temperature distribution or maybe thermal gradient, or also you can take a output request in the form of heat flow after you perform the thermal analysis, and the input and the load that you need to define as a thermal load.
Load.
So that thermal load, it may be your conduction, maybe your convection may be like free convection, forced convection, right? So here you need
Yes.
HTC, heat transfer coefficient, at what temperature, right? Conduction also, and maybe like you define a specific temperature also, and there is a radiation. Okay,
Yes.
so the steady state thermal analysis looks for the final state of heat transfer problem. Clear this statement?
Yes.
I'll repeat this statement. A steady state thermal analysis looks for the final state of the heat transfer problem. It looks for the final
Final state of the heat transfer.
state of a heat transfer, noted it, problem.
Yes.
So it is very efficient, steady state thermal analysis, very effective and very efficient to perform. Getting it?
Yes, sir.
Clear?
Yes.
What is the advantage? Advantage of doing a steady state thermal analysis is to simplify the system by avoiding very long duration run to get a stable results. Clear? What is the advantage? Advantage is, I'll repeat once again, what is the advantage of this steady state thermal analysis is, it is simplify the system of equations or system to avoid from a very long duration of run to get a stable results. Clear? If somebody asks you what is thermal analysis, if you want to describe what is thermal analysis, then how you will describe? What is thermal analysis in a one single line? Yes, for us.
Thermal analysis helps to find the distribution of temperature.
So if I want to describe in a one line, I'll start from the beginning, right? Heat transfer, correct? So the heat transfer is defined as an energy in transmit, right? From A to B, right? From higher to lower.
Yes.
The analysis of system, ऐसा analysis system, कोई ऐसा system है ना?
Yes.
The analysis of a system using the law of heat transfer is named as thermal analysis. Clear? The heat transfer is defined as an energy in transmit. The analysis of system using the law of heat transfer is named as the thermal analysis, right? So the solving the Fourier law of equation on the real life problem is difficult. So we need to convert that numerical method into matrix form, right? Matrix form means what? Nodes and elements, correct?
Yes.
So we know our universal equation. So see, we know that there is a Fourier equation, Fourier law of equation. That's very difficult to convert. So we have to convert into the matrix form. So in matrix form, there is a K, there is a T, and there is a Q, right?
Okay.
So where the K indicates conductivity stiffness, right? And here the T indicate the temperature, right? And Q indicates the heat load, or you can say heat flux, or you can say heat flow, like that, right? Etc. Correct?
Yes.
So in static analysis, we have an equation called K into displacement equals to force, right? K into D into F. So here we are having K into T into Q. So K indicates the conductivity stiffness, temperature, T indicates the temperature, Q indicates the heat flow, heat load, or maybe your heat flux. Okay. So heat flow means we know heat flow. Heat flow is a heat flow per unit time, correct? And heat flux is the heat flow rate per unit area.
Per unit area.
Clear? So what is the difference between heat flux and heat flow? What is the difference between heat flow and heat flux? So the heat flow is per unit time, and the heat flow rate per unit
area.
That's the difference, right? So the heat flux is constant and continuous in a steady state analysis. That we need to consider. That's a note, right? So the heat flux is basically constant and continuous in the steady state analysis. So this is the equation from Fourier equation to the matrix form of equation that software will solve behind the scene to arrive to the your required result in the thermal analysis. Clear?
Sir.